Hello, and welcome to Sleepy Bedtime Stories. Relax, get comfortable, and get ready for a peaceful bedtime story. Let's begin. The night the moon began to remember. There is a particular kind of stillness that belongs to the universe. It arrives not with fanfare, but with patience. The slow breath of time measured not in minutes, but in eons. In the space between stars where darkness is not absence but presence, where cold is not harsh, but simply the way things are. Tonight, we follow a story that began long before there were nights to follow. Before there was anyone to look up and wonder. Before there was a moon to catch the light and send it softly back to Earth. This is the story of how that moon came to be. In a place beyond time, as we understand it, in the early days of the solar system when planets were still learning what shape they should take, there was a world called Earth. But it was not the Earth you would recognize if you stood upon it today. This Earth was younger, hotter, restless in a way that made the most violent storms of our present world seem like gentle sighs. 4.5 billion years ago, the number sits in the mind like a pebble held in the hand, its weight impossible to truly feel. Billions, not hundreds, not thousands, billions of years, each containing 365 days, each day 24 hours, each hour 60 minutes. The mind cannot hold such vastness, but the universe holds it easily. Time, to the cosmos, is simply another dimension to move through, like walking down a long hallway where each door opens to a different age. The young Earth spun beneath a sky that had never known moonlight. Its day was not 24 hours long then. The Earth turned faster in its youth, the way young things often do. A day lasted perhaps 5 hours, perhaps 6. The planet whirled through space like a dancer who cannot stand still, rotating so quickly that time itself seemed impatient. There were no oceans as we know them. There were no trees rustling in evening wind. No rivers finding their patient way to the sea. No robins hopping along hedgerows. No cottages with uneven windows and cream-colored lampshades. None of the gentle, settled things that make Earth feel like home existed yet. Instead, there was magma, vast seas of molten rock, glowing orange and red like the coals in a winter fireplace, but on a scale that defies imagining. The surface was a liquid thing, flowing and churning, too hot for any solid ground to form for long. When meteorites fell from the blackness above, they did not crash into soil or splash into water. They simply melted into the restless surface, adding their mass to the growing world. The sky, if one could call it that, was thick with vapor. Carbon dioxide and water and nitrogen swirled in clouds so dense they would have crushed anyone foolish enough to try to breathe them. There was no blue. No soft gradient from azure to indigo as the sun set. Just a dim, angry red glow that filtered through the haze. And the Earth was alone. No moon rose over that horizon. No pale light reflected in non-existent waters. The Earth had no companion in its orbit around the young sun. It spun in solitude, a molten sphere finding its way in a crowded neighborhood of newborn worlds. But elsewhere in that same orbit, something else was taking shape. Another world. another accumulation of rock and metal and dust, gathering mass grain by grain, collision by collision. Scientists would eventually name this world Theia, after the Greek Titaness who gave birth to Selene, the goddess of the moon. The name is poetically appropriate. Even more lovely is the reason it feels right, the way some truths sound correct before we fully understand them. Theia was smaller than Earth, about the size of Mars, the red planet that would later become Earth's neighbor. If you could have stood on Theia and looked up at its own dim sky, you might have seen Earth in the distance. The two worlds shared the same orbital path around the Sun, separated by about 60 degrees of arc. They traveled together like two boats on the same river, neither ahead nor behind, but offset, following the invisible curves that gravity laid out like roads through the darkness. This arrangement is called a Lagrange point, specifically the L4 or L5 position, where the gravitational influences of the Sun and Earth create stable pockets in space, places where smaller objects can comfortably remain without being pulled too far in any direction. Theia rested in one of these gentle gravitational harbors, orbiting the Sun at nearly the same distance as Earth, neither approaching nor receding. For a time, this was stable. For millions of years, perhaps, the two worlds coexisted in their separate but related paths. Both continued to grow. Both continued to gather the debris that littered the early solar system. Dust and stones and boulders all gradually added their mass to the two growing planets. But nothing in the early solar system was truly stable for long. The orbits of young planets are not fixed lines drawn with a ruler. They are influenced by every nearby mass, tugged gently this way, nudged carefully that way. Jupiter's enormous gravity sent ripples through the whole system. Saturn did the same. Smaller worlds passed close, their own gravity adding tiny corrections to every orbit they encountered. Slowly, over eons too vast to picture, Theia's orbit began to change. The stable Lagrange point could not hold it forever. Subtle gravitational interactions accumulated. The orbit became less circular, more elliptical. The path began to cross closer to Earth's own trajectory through space. And eventually, 4.4 billion years ago, the paths converged. Imagine standing somewhere safe, impossibly far away, watching from a distance where the scale of what is about to happen can be comprehended. No soft gradient from azure to indigo as the sun set. Just a dim, angry red glow that filtered through the haze. And the earth was alone. No moon rose over that horizon. No pale light reflected in non-existent waters. The earth had no companion in its orbit around the young sun. It spun in solitude, a molten sphere finding its way in a crowded neighborhood of newborn worlds. But elsewhere in that same orbit, something else was taking shape. Another world. Another accumulation of rock and metal and dust, gathering mass grain by grain, collision by collision. Scientists would eventually name this world Theia, after the Greek Titaness who gave birth to Selene, the goddess of the moon. The name is poetically appropriate. Even more lovely is the reason it feels right, the way some truths sound correct before we fully understand them. Theia was smaller than Earth, about the size of Mars, the red planet that would later become Earth's neighbor. If you could have stood on Theia and looked up at its own dim sky, you might have seen Earth in the distance. The two worlds shared the same orbital path around the Sun, separated by about 60 degrees of arc. They traveled together like two boats on the same river, neither ahead nor behind, but offset, following the invisible curves that gravity laid out like roads through the darkness. This arrangement is called a Lagrange point, specifically the L4 or L5 position, where the gravitational influences of the Sun and Earth create stable pockets in space, places where smaller objects can comfortably remain without being pulled too far in any direction. Theia rested in one of these gentle gravitational harbors, orbiting the Sun at nearly the same distance as Earth, neither approaching nor receding. For a time, this was stable. For millions of years, perhaps, the two worlds coexisted in their separate but related paths. Both continued to grow. Both continued to gather the debris that littered the early solar system. Dust and stones and boulders all gradually added their mass to the two growing planets. But nothing in the early solar system was truly stable for long. The orbits of young planets are not fixed lines drawn with a ruler. They are influenced by every nearby mass, tugged gently this way, nudged carefully that way. Jupiter's enormous gravity sent ripples through the whole system. Saturn did the same. Smaller worlds passed close, their own gravity adding tiny corrections to every orbit they encountered. Slowly, over eons too vast to picture, Theia's orbit began to change. The stable Lagrange point could not hold it forever. Subtle gravitational interactions accumulated. The orbit became less circular, more elliptical. The path began to cross closer to Earth's own trajectory through space. And eventually, 4.4 billion years ago, the paths converged. Imagine standing somewhere safe, impossibly far away, watching from a distance where the scale of what is about to happen can be comprehended. Two worlds, each thousands of kilometers across, approach each other, not quickly by cosmic standards. This is not a meteor flashing through the atmosphere, but by any human measure, the speed is unimaginable. Several kilometers per second. Faster than any bullet. Faster than sound, than thought, than fear. Theia does not strike Earth head-on. If it had, the collision might have shattered both worlds completely, scattering fragments that would never recombine. Instead, Theia approaches at an angle, about 45 degrees, scientists estimate. A grazing impact, if such a word can be used for an event of such incomprehensible violence. The moment of contact arrives. Theia strikes Earth's surface at an oblique angle, and the universe changes. In that instant, an amount of energy is released that has no equivalent in human experience. All the nuclear weapons ever built, if detonated simultaneously, would be a candle flame compared to this inferno. All the volcanoes erupting at once would be a whisper compared to this roar. The outer layers of both worlds turn to vapor instantly. Rock that has been solid for millions of years becomes gas in the span of a heartbeat. The impact site glows brighter than the surface of the sun. For a moment, this one point in space becomes one of the brightest objects in the solar system. The collision drives deep into both planets. Theia's core, dense iron and nickel plunges through Earth's outer layers. Some of it merges with Earth's own core, adding to the metallic heart of the planet. But much of Thea's outer mantle, the rocky material that makes up the bulk of a planet's volume, is blasted into space. Earth itself is nearly torn apart. The impact imparts so much energy that huge sections of the planet's outer layers are thrown outward. Molten rock fountains into space, not in a neat arc like water from a hose, but in an expanding cloud of debris. Rocks the size of mountains, rocks the size of houses, rocks the size of pebbles. Vapor so hot it glows. All of it ejected into orbit around what remains of Earth. For hours, maybe days, the violence continues. The energy from the impact ripples through Earth's entire volume. The planet rings like a bell struck by an enormous hammer. Shockwaves circle the globe, meeting on the opposite side to create secondary zones of catastrophic heating. The entire surface becomes an ocean of magma kilometers deep. There is no solid ground anywhere. The planet glows red-orange from pole to pole, a wounded sphere radiating heat into the blackness. And surrounding this transformed Earth, a disk begins to form. The debris thrown into space does not simply fly away into the void. It is held by Earth's gravity, captured in orbit. The material spreads into a ring around the wounded planet, like the rings of Saturn but made of molten rock instead of ice. The disk is impossibly hot. Much of it is vapor rather than solid material. It glows with its own light, bright enough to illuminate the ruins of Earth below. This is a moment between worlds, between the old Earth that existed before and the new Earth that will emerge after, between a planet that orbited alone and a planet that will forever after be accompanied. In the disk, things begin to happen. Gravity is patient. It does not rush. It simply pulls constantly on every particle of matter. In the chaotic aftermath of the collision, as the disk of debris orbits the glowing Earth, each fragment feels the pull of every other fragment. The larger pieces, having more mass, pull harder. The smaller pieces drift toward them. Collisions occur, not violent ones anymore. These are gentle meetings, relatively speaking. Warm rock touches warm rock. Instead of shattering, they stick together. Mass accumulates. Small clumps become larger clumps. Larger clumps become boulders. Boulders become mountains. Mountains become something that might, with generosity, be called a moonlet. The process is surprisingly fast by geological standards. Computer simulations suggest it might take only a few thousand years, perhaps even less. Some recent research indicates the moon might have formed in mere hours after the impact, material flung directly into orbit already gathered into something resembling a sphere. But whether it took hours or millennia, the result is the same. From the disk of debris, a new world coalesces. It pulls itself together through the simple insistence of gravity. The material comes mostly from Thea's outer layers, mixed with fragments from Earth's mantle. The chemical signatures of both worlds are blended in the new sphere's rocks. There is no iron core or only a very small one. The iron from both planets has sunk to their cores, and the moon forms from the outer layers that were stripped away. This is why the moon is less dense than Earth. It is made of lighter materials, the rocky mantle rather than the metallic core. As the material gathers, the growing moon heats up. The energy of countless collisions, even gentle ones, adds up. The entire surface becomes molten. A magma ocean covers the newborn satellite, glowing in the darkness. For a time, the moon is a second sun in Earth's sky, though there is no one yet to see it. Slowly, the surface begins to cool. The vacuum of space is an efficient thief of heat. Where magma is exposed to the void, it radiates its warmth away as infrared light, invisible but powerful. A crust begins to form, thin at first, fragile, but growing thicker as eons pass. The moon takes shape, and in doing so, it begins to change the very nature of Earth itself. The newborn moon orbits close, impossibly close by today's standards. Perhaps only 24,000 kilometers away, where today it sits at 384,000 kilometers. The moon fills the sky, appearing 10 or more times larger than it does in our present age. An observer, if one could exist, would see a gigantic sphere hanging overhead, its surface still glowing faintly with residual heat. At this distance, the moon's gravity begins to reshape Earth. We must pause here to understand what gravity truly does. It is not simply a force that pulls things downward, though we experience it that way standing on Earth's surface. Gravity is a field that surrounds every mass, growing stronger the closer you approach. The strength falls off with distance, specifically with the square of the distance. Move twice as far away, and gravity becomes 4 times weaker. This means the moon's gravity pulls harder on the near side of Earth than on the far side. The difference is small but significant. Earth's diameter is about 12,700 kilometers. The difference in the moon's gravitational pull from one side of Earth to the other creates what is called a tidal force. This tidal force stretches Earth slightly, like squeezing a rubber ball from the sides, causing it to bulge at the top and bottom. But in Earth's case, the moon's gravity creates bulges pointing both toward and away from the moon. Why toward and away? It seems counterintuitive at first. The bulge pointing toward the moon makes sense. The moon pulls that side harder. But the far side bulges too, for a more subtle reason. The moon pulls Earth's center more strongly than the far side. So effectively, the moon pulls the center away from the far side, leaving a bulge behind. The solid rock of Earth does respond to this tidal force, rising and falling by several centimeters each day even now. But in the young Earth, still hot and partially molten, the response was more dramatic. The entire planet deformed noticeably, its shape constantly adjusting to the moon's position. But the most dramatic effect came later, after the oceans formed. As Earth cooled over the next 100 million years, water vapor in the atmosphere began to condense. Rain fell. It rained for centuries, perhaps longer. The oceans filled, and suddenly Earth had something much more responsive to tidal forces than solid rock. Water flows. Water moves easily. The moon's gravity pulled on the oceans, creating bulges of water on the near and far sides. As Earth rotated beneath these bulges, the water sloshed back and forth, rising and falling along the coastlines in the rhythm we call tides. High tide occurs when a location rotates through one of the bulges. The water piles up, rising along the shore. 6 hours later, that location is between the bulges and the water recedes. Low tide. 6 hours more, another high tide. 6 hours, another low. The cycle continues, twice daily, as long as the moon orbits Earth. But something else happens, something subtle and enormously consequential. The tidal bulges do not point exactly at the moon. They would if Earth did not rotate. But Earth spins, and the friction between the oceans and the seafloor drags the bulges forward slightly. The bulge on the near side of Earth leads the moon by a small angle, pulled ahead by Earth's rotation. This matters because that bulge has mass, and that mass has gravity. The near side bulge pulls on the moon, not just directly toward Earth's center, but slightly ahead in the moon's orbit. It is like a gentle push from behind, constantly applied, speeding the moon up. When an orbiting object speeds up, something counterintuitive happens. Its orbit gets larger. It moves farther away. This is one of the strange rules of orbital mechanics. Add energy to an orbit, and the object spirals outward. So the moon, pulled forward by the tidal bulge, gradually gains energy. Its orbit expands. It recedes from Earth. This process has been continuing for 4.4 billion years. At first, the recession was rapid. The moon was so close that the tidal forces were enormous. The bulges were huge. The pull on the moon was strong. It spiraled outward quickly, perhaps gaining several meters per year in the first epochs. As the moon moved farther away, the tidal forces weakened. The recession slowed, but it never stopped. Even today, the moon drifts away from Earth at a rate of about 3.8 centimeters per year, about the length of your thumb, annually. Measured by bouncing laser beams off reflectors left on the moon's surface by Apollo astronauts, this recession is one of the most precisely measured movements in astronomy. This means the moon was closer in the past, much closer. If we could travel back in time and watch the moon over eons, we would see it growing visibly larger in the sky. 620 million years ago, the moon was about 97% of its current distance from Earth. Larger in the sky, creating stronger tides. Days were only 22 hours long because Earth was spinning faster. 3.2 billion years ago, analysis of ancient sandstone formations suggests the moon was even closer still. The tides it raised would have been spectacular if there had been anyone to witness them. And there is more. As the moon gains energy and spirals outward, that energy must come from somewhere. It comes from Earth's rotation. The same tidal forces that push the moon outward also create friction on Earth, grinding against the seafloor, slowing Earth's spin. This is why our days grow longer. Not by much. About 2.4 milliseconds per century. You would never notice it in a lifetime. But over millions of years, it accumulates. Earth spins slower now than it did in the age of dinosaurs. 400 million years ago, there were about 400 days in a year, each about 22 hours long. The moon was closer. the tides were stronger. Everything moved faster. Eventually, billions of years in the future, if the sun does not interfere, Earth and Moon will become tidally locked. Earth's rotation will slow until one day equals 1 month. The Moon will stop receding. One side of Earth will always face the Moon, which will hang motionless in the sky. The other side of Earth will never see it, the Moon becoming the subject of myths and legends for those who live in permanent darkness from it. But that future is so distant that the sun will likely swell into a red giant first, possibly consuming both worlds. For now, the dance continues. The Moon recedes. Earth slows. The partnership evolves. We must speak now of what the Moon does for Earth beyond creating tides. The Moon stabilizes Earth's axial tilt. Our planet rotates at an angle of about 23.5 degrees relative to its orbital plane. This tilt is what creates seasons. When the northern hemisphere tilts toward the sun, it is summer in the north and winter in the south. 6 months later, the situation reverses. Without the Moon, this tilt would wander over millions of years. Computer simulations show that Earth's axis could tilt dramatically, wobbling between nearly 0 degrees and more than 80 degrees. The consequences would be catastrophic for life. The climate would swing wildly between extremes. Regions that were temperate would become uninhabitable. The Moon, through its gravitational influence, acts like a gyroscopic stabilizer, keeping Earth's tilt relatively constant. The seasons remain predictable. Life can adapt and thrive. The Moon also helps generate Earth's magnetic field. The tidal forces from the Moon, working on Earth's interior, help keep the outer core molten and circulating. This circulation of liquid iron creates the magnetic field that shields Earth from solar radiation and cosmic rays. Without it, the atmosphere might have been stripped away by the solar wind long ago, the way Mars lost much of its atmosphere. And then there are the tides themselves, which do more than just move water. In the intertidal zones, where the ocean rises and falls along the shore, unique ecosystems develop. Creatures that can survive both in water and in air. Plants that can tolerate being submerged then exposed. These zones may have been crucial for life's transition from sea to land hundreds of millions of years ago. The tides created an environment where evolutionary experimentation could occur, where organisms could adapt gradually to terrestrial conditions. The Moon has shaped Earth in fundamental ways. It is not merely a companion but a partner, as essential to Earth's character as oceans or continents. But there is something else the Moon gives us, something less tangible but no less important. Let us return for a moment to the evening that began this story. A woman in a small English town prepares for bed. She glances out the window and sees the Moon, hanging pale above the rooftops. It is a waxing crescent, a slim curve of light in the darkening sky. She does not know the Moon's history. She has not studied the giant impact or calculated orbital mechanics. But she feels something when she looks at it. A sense of connection, of continuity. The Moon has been there every night of her life, changing its shape in a predictable rhythm. A clock in the sky marking the passage of time. The Moon affects us in ways we do not fully understand. Perhaps it is simply familiarity. We are a species that evolved under a sky that included the moon. Our ancestors looked up at it for hundreds of thousands of years, long before they understood what it was. They saw faces in its markings. They created stories about it. They organized their calendars around its phases. The lunar cycle is 29 and a half days roughly. This duration shows up in many biological cycles, though the connections are often coincidental rather than causal. Tides affect marine life profoundly. Many coastal creatures time their spawning to the lunar cycle, using the extreme high tides during full and new moons to distribute their offspring. For humans, the moon has been a source of wonder and inspiration since we first looked up. Every culture has moon myths. Every language has words for its phases. The moon has been a goddess, a guide, a timekeeper, a symbol of change and constancy both. Tonight, it is simply a presence, a gentle light in the darkness. The woman closes her curtains and settles into bed. Outside, the moon continues its ancient journey across the sky, moving 12 to 13 degrees eastward each day, enough that it rises about 50 minutes later tomorrow than it did today. This is why the moon appears in different positions at the same hour each night. It is physically farther along in its orbit. The phases we see are a consequence of geometry. When the moon is between Earth and the sun, we see its night side. New moon. As the moon moves along its orbit, more of the sunlit side becomes visible. Waxing crescent. After about a week, half the moon is lit. First quarter. Then waxing gibbous, growing toward fullness. 2 weeks after new moon comes full moon, when a moon is opposite the sun in the sky, and we see its entire day side. Then the cycle reverses. Waning gibbous. Third quarter. Waning crescent. Until finally the moon returns to its position between Earth and sun, and the cycle begins again. The moon itself does not change. It is always half-lit by the sun, just as Earth is always half-lit. We simply see different portions of that lit half from our vantage point on Earth. And the moon keeps the same face toward us always. This is called tidal locking, the same phenomenon that causes the moon to recede. Over millions of years, Earth's tidal forces on the moon slowed the moon's rotation until its rotational period matched its orbital period. Now it rotates once per orbit, keeping one side perpetually facing Earth. We call this the near side. The far side, often incorrectly called the dark side, receives just as much sunlight but is never visible from Earth. The moon shows us slightly more than half its surface over time due to libration, a subtle wobbling caused by the moon's elliptical orbit and tilted axis. But primarily, we see the same features, the same dark Maria, which early astronomers thought were seas, and which are actually vast plains of ancient lava. The same bright highlands. The same craters, formed by billions of years of meteor impacts. When we look at the moon, we are looking at a museum of solar system history. The craters tell stories of the bombardment that all inner planets endured. The Maria speak of a time when the moon was geologically active, with lava flooding out from its interior to fill the largest impact basins. The lighter soil, called regolith, records billions of years of micrometeorite impacts, grinding the surface rock into powder. And all of it formed from that ancient collision between Earth and Thea. The violence of that moment, incomprehensible in its scale, led directly to this gentle presence in our night sky. Destruction became creation. Chaos became order. Two worlds ended, and in their ending, a new world began. This is the way of the universe. Nothing is permanent. Everything changes. But change is not random. It follows laws we have learned to understand. Gravity, momentum, energy conservation. The rules are simple, but their consequences are infinitely complex. The moon teaches us this. It was created in violence and has traveled toward peace. It was once so close it filled the sky and has gradually moved toward distance. It once orbited a barren, molten Earth and now looks down on a world rich with life and complexity. It has been witness to every moment of Earth's history since its formation. The cooling oceans, the first stirrings of life, the rise of oxygen in the atmosphere, the age of dinosaurs, the ice ages, the emergence of humanity. And through all of that, the moon has maintained its gentle presence, rising, setting, waxing, waning, a reliable rhythm in the chaos of change. Scientists can tell us how the moon formed. They can measure its recession with millimeter precision. They can explain tidal forces and orbital mechanics and isotopic signatures. And all of that knowledge is beautiful in its own way, a testament to human curiosity and intelligence. But there is another kind of knowledge that comes from simply looking up on a quiet evening and seeing the moon hanging there, knowing that it has hung there for billions of years, that it will hang there for billions more, barring catastrophe, that the same moon you see tonight was seen by every human who has ever lived, that it connects you to the deep past and the distant future simultaneously. The woman in the English town sleeps now. Her breathing has matched the gentle rhythm of rest. Her mind has released the concerns of the day. Outside her window, the moon continues its patient arc across the sky, moving toward the western horizon where it will set a few hours before dawn. In the morning, she will not remember looking at it. The moment will blend into all the other quiet moments of evening. But somewhere in her mind, perhaps, there is a sense of having been accompanied through the night. The moon has been there, as it always has. As it always will be, for as long as Earth and moon exist. This is the gift of the moon. Not just tides or climate stability or navigational guidance, though all of those matter. The gift is presence, constancy, a reminder that we are part of something larger and older than ourselves, that the universe operates on timescales we can barely comprehend, and yet we can glimpse those timescales when we look up and understand what we are seeing. The moon formed 4.4 billion years ago from the debris of a catastrophic impact. It is approximately 3,474 kilometers in diameter. It orbits Earth at an average distance of 384,400 kilometers. Its surface gravity is 1/6 that of Earth's. It has no atmosphere. No water on its surface, though ice exists in permanently shadowed craters near the poles. No life has ever evolved there. It is a dead world, geologically speaking, though not completely cold. Its interior still retains some heat. But numbers, while accurate, miss something essential. They describe the moon, but do not capture what it means. For that, we need different words. The moon is a companion, a witness, a marker of time, a source of beauty and wonder, a reminder of where we came from and how fragile and precious our home planet is. When we see the moon, we are looking at a piece of Earth that was torn away and reformed. We are looking at our sibling world, born from the same catastrophe that nearly destroyed us. And the moon is moving away, slowly, 3.8 centimeters per year. By the time you finish listening to this story, the moon will be microscopically farther from Earth than it was when you began. The distance is growing. The tides are weakening imperceptibly. Earth's days are lengthening by milliseconds per century. The dance continues, evolving, changing, but so slowly that we cannot perceive it in our brief lifetimes. This is perhaps the most profound lesson the moon teaches. That time is vast. That change is inevitable, but often too slow to notice. That what seems permanent and unchanging is actually in constant motion. That the universe is patient in ways we can barely imagine. The night deepens. The moon, now past its zenith, descends toward the west. Its light falls on cities and forests, on oceans and mountains, on places where people sleep and places where they work through the night. The same light that has fallen on Earth for billions of years. Sunlight, reflected and softened, turned from the harsh glare of day into the gentle glow of night. Somewhere, a child lies awake, looking out the window at the moon and wondering what it is. The questions bubble up naturally. What is the moon made of? How far away is it? Why does it change shape? Could we go there? Those questions led, eventually, to human footprints on the lunar surface. 12 astronauts have walked on the moon. They brought back samples. They placed reflectors that we still use to measure the moon's distance. They looked back at Earth and saw it as a blue marble hanging in the blackness, fragile and beautiful. Those journeys to the moon expanded our understanding of where we came from. The rocks the astronauts brought back told the story of the moon's formation. The similar isotopic compositions of Earth and lunar rocks confirmed they shared a common origin. The lack of a large iron core suggested the moon formed from the outer layers of a planet, not from a complete world. All the evidence pointed to the giant impact hypothesis, once considered radical, but now widely accepted. We understand the moon better now than at any point in human history. But understanding does not diminish wonder. If anything, it deepens it. Knowing how the moon formed makes it more remarkable, not less. The chain of events that had to occur, the formation of the solar system, the accretion of planets in similar orbits, the gradual destabilization of Thea's orbit, the impact at just the right angle and speed, the coalescence of debris into a stable satellite. Each step was contingent on countless factors aligning correctly. If any of those factors had been different, Earth might have no moon, or multiple small moons, or a moon that spiraled back into Earth long ago. We might be living on a world with wildly unstable seasons, no tidal zones, weaker magnetic fields. Life might never have developed, or it might have developed in completely different forms. The moon we have is the result of a specific history, and we are the result of that history too. Everything that happened to Earth happened because of the moon's presence or happened in spite of it. We cannot separate Earth's story from the moon's story. They are the same story, told from different perspectives. The woman in the English town breathes softly in her sleep. The clock on her bedside table ticks. Each tick represents a moment of time passing, 1 second after another, accumulating into minutes and hours, and eventually days and years and lifetimes. The moon keeps its own time. A synodic month, from new moon to new moon, is 29.53 days. This is slightly longer than a sidereal month, the time it takes the moon to return to the same position relative to the stars, which is 27.32 days. The difference occurs because while the moon orbits Earth, Earth orbits the sun. The moon has to travel slightly farther to return to the same phase. Ancient peoples used the moon to mark time. Many calendars were lunar, based on the moon's phases. The Islamic calendar still is. The Jewish and Chinese calendars are lunisolar, attempting to sync lunar months with solar years. Even our modern calendar, though solar, preserves traces of lunar timekeeping. The word month comes from moon. The moon gave us a way to measure time longer than a day, but shorter than a year. It gave us a rhythm to organize our lives around. Plant crops after the new moon. Harvest before the full. Meet when the moon is in its third quarter. The phases provided a shared reference point, visible to everyone, unchanging in its pattern. We have atomic clocks now, more precise than the moon could ever be. But the moon was humanity's first clock, and it worked well enough to build civilizations around. As the night continues, the moon moves through the sky. An observer tracking its position carefully would notice it shifting about half a degree per hour. This motion is actually the moon's orbit becoming visible. The moon travels its orbit at about 1 kilometer per second, fast enough to circle Earth in 27 days, slow enough that its motion is imperceptible except over hours. By dawn, the waxing crescent moon will have set. The sun will rise, and the moon will be somewhere on the day side of the sky, invisible in the glare. But it is still there, always there, even when we cannot see it. This is important to remember. The moon does not disappear during the day or during a new moon phase. It is always present, always orbiting. We simply cannot always see it. Much of existence is like this. The things that matter most are often invisible or taken for granted. The air we breathe, the ground beneath our feet, the gravitational field that holds us, the magnetic field that protects us, the moon that stabilizes us and marks our time. We live immersed in systems we barely notice until we learn to look for them. The moon teaches us to look, to notice, to pay attention to the slow changes that shape our world. It teaches patience. The moon's phases cannot be hurried. They arrive in their own time. We cannot speed them or slow them. We can only observe and adapt. The moon teaches scale. Looking up at it, knowing it is 384,000 kilometers away, helps us begin to grasp the vastness of space. And knowing that is nothing compared to the distance to the sun or to other stars, helps us understand how small our corner of the universe is. The moon teaches history. Every crater tells a story millions or billions of years old. The surface is a record of impacts stretching back to the solar system's formation. We can read that record and learn what the early solar system was like, how often impacts occurred, how that rate changed over time. And the moon teaches us about ourselves. We are creatures who look up, who wonder, who ask questions and seek answers, who traveled 250,000 miles through space to stand on another world and look back at our own. That impulse to explore and understand is distinctly human. The moon was our first destination beyond Earth, and it remains a symbol of what we can achieve when we decide to do something difficult. The woman in the English town will wake with the dawn. She will go about her day. Work, perhaps. Errands. Conversations. The small necessities and pleasures of life. She probably will not think about the moon. Few people do during daylight hours. It seems irrelevant to daily concerns. But tonight or tomorrow night or next week, she might glance up again. The moon will be a little fuller. The crescent will have grown into a quarter, then into gibbous, working toward full. She might note the change or she might not. Either way, the cycle continues. The moon does not require our attention to do its work. It simply is. And that is enough. As this story draws toward its end, the moon continues its ancient journey, orbiting Earth, receding gradually, reflecting the sun's light, creating tides, stabilizing Earth's axial tilt, being a companion and a clock and a constant presence. For 0.4 billion years of history distilled into a gentle light in the night sky, violence transformed into beauty, chaos giving birth to order. Two worlds colliding and creating something that would become essential to a third world not yet imagined when the collision occurred. Life on Earth, including the woman in her small house in an English town, exists because of a catastrophic impact that no living thing witnessed and that occurred so long ago the numbers ceased to have meaning. And yet here we are. The moon is there. Earth is here. Life flourishes. Consciousness arose. We tell stories about how it all began, and our stories get closer to truth as we learn more. Science reveals the mechanisms. Poetry reveals the meaning. Both are necessary. Neither is complete alone. So, as you prepare for sleep, think of the moon if you wish. Or do not. It makes no difference to the moon. Its work continues regardless. But knowing it is there, knowing where it came from and what it does, might bring a sense of connection. A thread linking you to the deepest past and the farthest future. A reminder that you are part of a universe that is both unimaginably vast and intimately connected in every detail. The moon rose tonight, as it does every night. It will set in a few hours. Tomorrow it will rise again, 50 minutes later, in a slightly different position, showing a slightly fuller phase. The dance continues. Earth and moon together, partners in space, shaped by each other, bound by gravity and history. And tonight, that is enough. To know the story, to feel the connection, to rest beneath the same sky that has sheltered life on Earth for billions of years, with the moon keeping watch. The woman sleeps. The moon travels. the earth turns. And somewhere in the vastness of space and time, the pattern continues, too large for any single mind to hold, but beautiful precisely because we can glimpse small parts of it and understand. That is the story of the moon, not just how it formed, but what it means. A companion born from catastrophe, a constant presence in a changing world. A reminder that even the most violent beginnings can lead to gentle endings. If you found this story helpful in your journey towards sleep, consider subscribing to this channel for more bedtime stories that blend science and wonder. Press the like button if the moon's story resonated with you. And as you drift off, know that the moon continues its patient work, just as it has for billions of years, just as it will for billions more. Rest well. The moon is there, and that is enough.